in space also it is going on, and that waves is called as gravitational waves, which is created by the gravity. The gravity creates the gravitational waves in a spherical, not in a sine wave, and as you can see, the light wave, not like that. It will gives us in a circular manner. The gravitational wave travels with the help of a space-time fabric, and the next third messenger is neutrinos. Neutrinos are not visible, it is invisible, nearly massive ghost particles, and that pass through your body every second, caught by detectors like ice cube. We take ice cube and isopropyl and put in mm, transparent uh, rectangular cube, and that in that we will put isopropyl and ice cubes, and after that we will close the lid of the top, and after seeing it and put the camera towards that empty area. After when we put cover the lid and put the ice cube and isopropyl, we can see that there is happening some sparks and creating some light. That is called a neutrinos. We detect like that, but it is nearly impossible to see. And ghost particles we can't see from a bare eyes. We have to we make some instruments, and so under certain condition we can see it, and it is coming from a far distance from the universe, and the source we don't know. That is neutrinos, and the cosmic rays. The cosmic rays are high energy particles that arrive from beyond our galaxies, like black holes, and they emit cosmic rays, and other supernovas and other cosmic events. They emit the cosmic rays. When we catch these messengers, we decode the study of the universe. So the cosmic ray is coming from the far distance. The source is unknown, and that source is emitting the rays. That is called as cosmic rays. So these are the four messengers of cosmic, which we detect the what is happening there in our universe. This help us to don't go to near stars and black holes and study there only. By here itself, we can study by through these four messengers. And there is a next go to the next exoplanets. And in exoplanets, right now we have discovered 5,900 exoplanets. Until a few decades ago, we only knew of one planetary system, our own, that is solar planetary system. And today we know 5,900 plus confirmed exoplanets. How it is. And the number keeps rising because the universe is vast. As we keep on discovering, it becomes more discovery and more mysterious. And the transist method, how do we find them? We find by three methods. The first one is the transist method. What it is? A star becomes slightly dimmer when a planet crosses in front of it. I will tell you the simple example for it. Imagine if you are watching a movie in a theater, and the projector is on, the movie is on, a cinema is started, and if the person stands up and um, comes in front of the projector rays, it will block that rays, and behind him you can see the block person's figure in the cinema theater. That figure you can see it. That figure is black, and it appears to be black because the uh, light projector light is blocked by him and hitting him instead of the screen. So we observe that black area. Similarly, what we do is that the all in our galaxy has a star. If a star has means the star around the star there must be planets. That planets is habitable or not, how we determine? We will determine if the star is there, we will detect its luminosity, how much light it is emitting per second. Per second, how much photons it is emitting, and we will see that rate of the emission, and we will look around for not for one day and the 1 week. We will look around years and so many days, and after looking it, we will put a graph, a time versus brightness, time versus brightness, or flux versus brightness. We will put it. After putting it, what will happen is there will be see some depth, because when the planet enters in front of the star, then the luminosity will decreases. When the luminosity decreases, we say that there is a planet. If how we determine there is a planet or not? There may be one planet, two planet, three planet. How we will determine? We will determine like we see the pattern of the graph. If the pattern of the graph is similar, and we say that there is one planet. If the graph shows the two characteristic graph, two types of graph, like one depth is nearly sharp, and another depth is like a rectangle, step down. One is step down and one is a sharp brightness down. We will say that okay, there is a two planets in that star. So like that we determine the planets in our universe, and still now they are detecting the planets, exoplanets. NASA is working on it, and detecting the planets also. And the second one is radial velocity, how we see the planets from the radial velocity. The star wobbles under the gravity, and like that we will detect the planets from the gravity itself. That is called radial velocity. And direct imaging, we capture the planets by direct lights itself, like we capture the photos of the Mars. That is direct imaging. We will put the camera and take the photos of the planets. Like we take the photo of the Mars, photo of the Venus, photo of the Saturn, photo of the Jupiter, like so on. Like that is called direct imaging. So this was the detection of exoplanets in our universe. Let's see about the stars. And also JWST is now read the atmosphere of its worlds. And let's see about our stars. The star force everyone atom in you. Now look at your own hand for a moment. Look at your own hand, left or right hand. And every oxygen atoms you breathe, every carbon in your body, every iron atom in your blood was forged in a star. It was all created in a star, and then scattered in a space by supernova. Supernova happened. Supernova is nothing but imagine a pressure cooker, and a pressure cooker is full of pressure, and it crossed the limit of the pressure. You don't turn off the gas, and the pressure cooker will be boiling and boiling. The pressure is created in pressure cooker so much that it breaks the limit of the pressure cooker and comes out of the pressure cooker, and the pressure cooker will blast suddenly, like a gas cylinder. It will burst due to a gas cylinder will burst due to of a fire. That is a wrong example. The pressure cooker will blast like there is full pressure in the cooker, and after the limit cross, it will blast like that. So supernova has also its own limit on pressure inside the star. When it exceeds the pressure, the star will burst out. And stars are the factories of the universe. Stars only created the gold. The stars only created the diamonds. The stars only created this worlds. In chemistry, when you are in a high school or graduations, they tell chemistry tell us that the to detect to take elements from the any gold or iron or any elements, we have to go to the earth crust and dig, and you will get the elements. But they didn't say that how their elements came, how the elements came in the earth crust, where it came, or it is formed genuinely, organically, or what. It doesn't say. But in reality, it is made from the stars only. The star create the reactions. Like from it starts from hydrogen. The hydrogen will start burning, and there is nuclear physics in it, and that says that the nuclear physics, the hydrogen will become plus one nucleus will be adding, and also electrons will be adding due to reaction, and lots of electrons and nucleons are available in the space, so it will react with it and burn, and the byproduct will be given, and that byproduct also react with other electrons and become one thing. And by this reaction cycle, the carbon is generated, and nitrogen is generated, and oxygen is generated. Like that, there is a large amount of CNO cycle, we say, in star. That cycle is created, and that cycles create the diamonds, golds. And when the stars will collide, and that becomes makes the R process, rapid nuclei process, and that rapid nuclei process, what does that? It will make elements and make the meteoroids. We see the meteoroids now. Like that, it will make the meteorites, and that meteorites, what happens? It will go and crash to the Earth or any planets which is nearby, and to go and crash to the planets, and in that planet there will be seeding of the life or the elements. The a planet, if the meteoroid has elements, it go and crash the planet, and in inside there will be elements. Like that, we get gold, all elements by the star only. The star created the meteoroids, and meteoroids created from the space and hit the earth, and in earth we see the gold, diamonds, and other carbons and all. So it is basically created from the this stars only. And for this the third spring result diagram, and this shows us that life path of every star from birth to death. Low mass, like our sun, gently fade into white dwarfs, and high mass stars collapse into neutron star or black hole, he says. Like there is a limit, and that star should have some mass to become a black hole. When it exits that limit, then that star will become a black hole. If it doesn't exit that criteria of the mass, it become a white dwarf star, like a, light bulb, zero bulb, like that becomes, or like a neutron star, like a neon light, we can say. Like that will become, or exit the limit, it will become as a black hole. And you are not separate from the cosmos. You are made of stark Vikrage. Stars only we have all created, all the elements in the universe is created. And here you can see the graph here on the right side, which is given by Hertzsprung Russell, the two scientists worked on the stars and give the a graph. I won't go that much deep in it. In y-axis, they have given luminosity, and in x-axis, and they have given, I think it is spectra of it, and luminosity and absolute magnitude is given. It says that how the star is born and dead, and white dwarf luminosity level, energy level, and main sequence, and supernovas energy level and luminosity. It gives the overall study of the star from birth to death. It gives it from the graph itself. So, against the temperature, the brightness against the temperature, it is in the graph, and this graph tells the whole story about the stars. And this was about the star. And let's see about galaxies. What is galaxies and the invisible hand in it? Our sun is just one of star among 200 to 400 billion galaxies. We are in a Milky Way galaxy. In that Milky Way galaxy, there is so many of the planets and stars are there, around from 200 to 400 billion. Bared spiral galaxy. Our Milky Way is a spiral galaxy. When scientists measured how fast stars orbit at the edge of the galaxy, they found something strange that the you can see the graph here on the left side in white image, and in y-axis there is a velocity of the stars, and in x-axis there is a radius of the galaxy. From center of the galaxy we are the radius goes on. The when the distance increases, we accept that the velocity of the star should increase, and as the radius increases, the velocity of the star should be decreased, as we know, and all the data we have collected from it. But in reality, it doesn't happen. Maybe the universe wants to tell us something which we don't know, and we accept the graph which is not the dotted line. The dotted line is the expected, but it is not expected. And the high graph, you can see the strong, the bold straight line. That straight line is called expect reality. In we see that it doesn't decreases as the radius goes on. It becomes some constant, and then after the far distance, then it will decreases. So for making the graph look like this, there must be two possibilities. The one possibility is that we make mathematics calculation wrong, or there is something in the galaxy which making the graph look like, and that matter we don't know, because the calculation is perfect. We have supercomputers, so many computers, quantum computers, so that make doesn't make us that big blunder. So at the last we came to know that, and this is by dark matter, and the matter which we don't know, so we say that it is a dark matter. It is something dark, we don't know about it is. And when scientists measured this and found this dark matter, the outer star uh, are moving much faster than they should, and visible matter alone cannot hold them, and something invisible is there. We call it dark matter, and the rotation of galaxies is one of the strongest. Uh, is one of the strongest pieces of evidence that most of the matter in the universe is completely invisible to us. So, and if this dark matter doesn't exist in the galaxies, the Earth and other planets wouldn't be in existence. Because the if the dark matter is not in existence, then the spiral galaxy will become break and spread out in a rapid direction, like throwing sand in air. How it goes, like that, the spiral galaxy it goes in all direction, and the it will crash, and the we don't look at this beautiful spiral galaxy. To for looking at this beautiful spiral galaxy and existing Earth, and we are living in Earth. It is all because of dark matter. So we should thank to dark matter because we exist due to the dark matter only. If the dark matter is not there, the spiral galaxy would not be looking like this beautiful, and it would break the spiral symmetry and go so rapidly somewhere. So it is very important, and we are also looking on it. And the first scientist who discovered is Vera C. Rubin. She was a scientist. She discovered the rotation data of the collected from the telescopes. She detected the by Doppler velocity. The velocity is discovered, and that is studied. After studying this, she discovered that there must be some dark matter and said about this dark matter. And in our whole universe, how much percent of dark matter is there? Means there is 95% dark matter, which we don't imagine. And this is not only dark matter and dark energy. Dark matter plus dark energy. Dark matter plus dark energy is this much amount of percent is existing in our universe. So there is a lots of things to be known in the universe, and the proton, electron, and neutrons and atoms which we know that exist in our universe is only around 5% only. So it is very less percent we understand our universe, and we should look more into our universe. That is 95% of the universe remains unmapped. So there is lots of things to be discovered, and we are living in a universe that is mostly still unmapped. That is why we need new minds. That is why we need you. And this was about dark energy and dark matter. Let's see the tools which we require for this modern discovery. So, how does modern astrophysics actually work? How is the modern astrophysics actually work? We should we write a pen and paper, or we took any high level technique in this. We look it. The force tools now work together. That is theory, which is laws of physics. We know it. That is the first tool for the discovery. And observation, that is catching light and other messengers, which I said the four messengers: light, electromagnetic waves, and gravitational waves, and neutrinos, and cosmic rays. These four messengers we observe. That is the second tool. And third tool is simulation. We create virtual universes on supercomputers. Like we play a game, like a car racing game. It is not a real car, but we play in the mobile or a PC virtually. That is not in reality, but we play in a PC or mobile by virtually. So like that, we create the simulation, not like cars. We create stars and black holes in simulations. And artificial intelligence, the fourth. The artificial intelligence is growing rapidly right now. Everybody is using AI. Someone use AI in a perfect manner. Someone use don't. Some people know how to use AI. Some people don't know how to use it. And the AI is not just only text and image or videos. It is also finding patterns in millions of data points. It will detect if there is any wrong in the data, or is the data is saying something. It will detect and tell us that there is error in this data, or it is this data doesn't exist. Like that, it will study the data. And right now, there is one telescope that is named James Webb Space Telescope that is rewriting textbooks every month. We discovering the lots of things from this space telescope, and it is challenging our physics. And here it is a telescope, you can see it. And this telescope is the James Webb Space Telescope. And the second telescope right now is Vera C. Rubin Observatory. And this observatory is sending out millions of alerts every single night. It is sending the signals out a million of alerts it is sending in the single night. And the third one is the Roman Space Telescope. This telescope is uh, right now it is not launched. It is planning to launch on 30th August by NASA. They are launching it to mainly focused on the three topics: dark matter, dark energy, and exoplanets. So it will study this, detect the exoplanets and dark matter, know about it, and then study the data. And it is in honor to Vera C. Rubin, the telescope named as the Roman Space Telescope. And the next one is there is ELT. ELT means extremely large telescope. How lazy they are in naming. See, it is saying that extremely large telescope. If we make this telescope in one large, then we say that very extremely large telescope. Somewhat like that. They can see like that. And this telescope are coming online soon. And this is the golden age of discovery. And you are arriving at the perfect time for this field. So this was the all four tools we right now, and these are the four telescope. The above two telescope are in existence right now and working online, and below two is the right now it is under construction and launching, and it is soon to be online. So this was about the four tools, and right now we will tell about what should you do right now, what you should do right now for this entering this field. And astronomy and astrophysics or cosmos, and you launch a pad starts here. And now the most important part of tonight is how do you begin, how do you begin in this field. Here are four clear steps. I tell, listen it clearly. The first step is master the fundamentals, whatever it is. Master the fundamentals, like it is a wave optics or circuits, or studying about any chemistry or mathematics. You have derivations in mathematics, and you have to master in physics, know about all physics, classical physics, quantum physics, how the wave and the dual nature of matter, like we say that light and wave both acts in same time. And like that we have to master the physics and know about some fundamentals of it. And we should also mathematics, because if there is no math, then is no physics. The both are interconnected. So physics and math, if you should focus on it, on this subject. And also you should make some basic Python knowledge also, not that full high level Python level, basic Python level. You should know about it. And the second one is run small project using public data and citizen science. Like there is so many data available in internet. You can see it, like any data. And also ISRO has also ISDCC. It is openly data source for everyone. You can take the data and make studying that small data projects, like taking small datas and studying it. And also in citizen science there is available, or you take guidance from any Indian space team how to collect these data and study the data, and make a small project on which you are interested. And third one is apply the internship and summer schools, and actively apply for internship in university or institutes or research centers in which you are interested. Like if you want to become astrophysicist, apply for IIA or other uh, Aris is there, and that you should start applying the internships and summer schools also. Try attending the summer schools and this kind of webinars and like that. So it will give basic knowledges and how to come into field and do the research you will get it. And the last one is build online research presence. Like you say that I have done this research, I have done this research, and for authentic verification, whether you would have make this research or not, or it is just you are saying only, no any proof for that research authentication. You should apply that research in ORCID. It is a genuine platform for the new researchers, student researchers, and it is a best platform to share your research projects in that. So after this, you go on to the ORCID. It is available universe all over. It is universal website. All the countries available in this ORCID. So go into that and create an account in ORCID and make the presentation and make the upload the your research whatever you do, like you do a research on exoplanets and detect the planets from the transist, as I said, that you uploading that ORCID, like that you whatever research you have done, that you upload in the ORCID, and you do not need to wait, you will finish your degree. After degree we will do the research. Don't think like that, because you can start becoming an astrophysics from this week only. You not need to become a researcher after completing your whole degree and start doing in MSc or PhD. You might think like that. Because don't do like that, because and if you start at that time, you have to start from zero. You don't know about any basics or any things in that field, astrophysics or astronomy, and it will be hard to digest and become researching in these projects. And if you start from now only, what will happen is that you will get a broad idea. What will be the mistakes I can do? What will be the basic the fundamentals in this area? So you will get an idea from this now only. Start from here only, and whether it is failing or not giving, also start from now only. And if you start from now only, you will do get a better research in field of whichever you want. So the right time to start is now. And we go to next, and the time is running up. I will wind it fast only. And here there is five sources that work, and the five sources are, I have selected the five resources that actually work and cost nothing. That first one is uh, OpenStax Astronomy, a complete free text tube. Like you learn fundamentals from this text tube. OpenStax, there is astronomy. You can go and search in internet. And second resource is uh, AstroPy and Python tutorials, the real working tools. Like there is lots of YouTube videos on AstroPy and Python tutorials. So go and study it. And third one is NASA and ESA public archives. And there is a website called NASA SDS, SDS, and in that you will get lots of archives in that, and is a public archive also, full of observation data which you want to need. And fourth one is, okay, I mentioned three only. Okay, the fourth one is Arvik's review papers that show how the current frontier is. The RV, ARXIV. You can go and search there. You will get lots of papers, and the best also I can say Google Scholars. You can also get it from the research papers from Google Scholars also. So and then from there you can get it. And the last one is citizen science platforms that need volunteers right now. That resources also you can get, and they also need some volunteers. They can assist him, and you will also get some experience in that field also. And you do not need money to begin. You just need curiosity and consistency and the skill and the technique of asking skill questions that you should have. You don't have to have money to start the begin in this field. So this was my presentation, and the cosmos is waiting. And I want to leave with one final thought. Carl Sagan once said that we are the way for the cosmos to know itself. The universe is not waiting for perfect people. It is waiting for the curious ones who decide to start. You are not too late. You are not too ordinary. You are exactly where you need to be. And tonight, you look the first step. I can say it. So at last, I will say you one thing that if you study physics just to understand physics, you never understand it. If you study astrophysics just to understand astrophysics, you will never understand it. Similarly, if you study mathematics just to understand mathematics, you will never understand it. I will leave it to you as a riddle. When you find it out, when you will understand it, then you are on the right track. So I will not tell the answer for this riddle. I will leave it this riddle to you. You only decode it, and when you decode it, you will have the broad idea, and you will be in the right path. I can assure you. So this is my presentation regarding this, how to start your career in this astronomy and astrophysics, and all the broader topics I have covered. And thank you for the joining, and for your curiosity and patience listening for this presentation. And the now I would love to hear from you. Any questions, big or small, is welcome. After this, you can join the community and register for the next session, or want any projects to do, you can do it. And the cosmos is waiting. Let's go meet it. So thank you. If you have any questions, please ask me. Hello.
Yeah, sir. You audible.
Okay.
If you have any question in the audience, please put in chat box, or you can self unmute yourself, and then you can ask.
Yeah.
Okay, I think there is no more questions, and I thank to the Sri Hari sir, and very thank you so much, sir, for the valuable time and you are giving us, and we are a lot of learn about from you, and I think it is a wonderful session. We are listening you, we are learn from you, and also I want to say that the Sri Hari sir is the currently chairman Indian Space Team and head of Space Division Indian Space Team. So he is currently lead all the projects under the Space Science Division. And I think, sir, one question is coming from Tarun. Tarun is want to ask, what is the dark matter?
Okay. What you think about the dark matter, sir? Is really there? Yeah, sure, Arun. Because it is like we detect the velocity of the stars in the galaxy. The galaxy has so many stars. We detect the velocity of the stars. We see by Doppler shift, and we detect the telescope detects the velocity of stars. As the distance from center of the galaxy increases, the velocity of a star should decrease as the distance increases. But in reality, it happens not like that. It becomes some like a constant, then reduces, because for this happening in the graph, there must be two reasons. As I said, there must be one calculation issue, mathematics wrong, or there must be some matter in the galaxy that is making the graph look like this. As you know about the force, force of attraction given by Newton's law, that Newtonian physics, has gravity, and if there is radius increases, the force of the attraction should decrease. The Newton say that the laws of gravitational, universal law of gravitation, the universal law, inverse square, it should decrease when the gravitational force attracts should decrease as the distance increases between them. Similarly, the galaxy distance increases, the velocity of the star should decrease, because the distance between the star and the galaxy of the center is so much far, then there must be decrease in the what you say velocity. But there is no decrease in the velocity. Why it is not a decrease in the velocity? There must be some matter in the galaxy. So adding that matter, we don't know that matter is there. We assume, we put the calculation of the mass which we know in the galaxy, which all the mass, the galaxy of the mass of the stars, mass of the this gases in the galaxies, and mass of the anything material things in the galaxy. We all that which we see, and we add that mass and put the formula that we get, and this says that this matter is not only in the galaxy. Beside this, there is another matter which we don't know, and it is also invisible. And you can say that is not visible. And how we detect that matter? You can say, but it is not visible, but it has a mass. Mass has means it should have some gravity. So by gravity, we detect from it by gravitational waves. How it is detected from the LIGO? It is detected. The LIGO is a observatory center. That LIGO means laser interferometer gravity observatory. You can go and search LIGO. You will get the space observatory images of that. So by that detecting the gravitational waves, we say that the dark matter is in existence, and we put the beside the dark matter and put it as the formula. But in that, what it says that the galaxy should not exist in spiral galaxy. It should be cut off and break down and spread everywhere in 3D direction, 4D direction. And it should spread out, and the our Earth wouldn't exist, and any other planets wouldn't exist without the dark matter. So we should thank to dark matter, because of that only we are existing. In simple word, I will say that in last, I won't take much time. Like you have seen the pizza, na? The pizza, before making the pizza, there will be powder of the wheat. That powder is made dough in round